So here we go. We've got this one single step here. And, I could double click over here in the navigation, or I could double click right here. So I'm just going to double click right here and pull up this interface. And you can see we've got actions, supervision, and interlock, okay? Because there's no transitions coming in, there's no transitions coming out. But let's go ahead and give ourselves a transition going out so we can explore that at the same time. Okay, so I'm just going to come down here and create one transition going out. And now when I go back into here, now you can see I've got this T7, this new transition defined. Okay, so if I minimize all of that, that's what we're looking at. So what are these things? Interlock, supervision, actions, and a transition. Well, interlock, this is looking for something to be true that's going to permit this step to start. Okay, just because we've transitioned from one step to the next, or just because we've started this process, that does not necessarily mean that we want to go ahead and start taking all of the actions inside of here. Okay, so maybe there are some things that even though we're in this step, we want to have an interlock here that's going to allow us to control when those things start or not. And, are there, other places that we could put this kind of functionality? Yes, but it's here anyway. So we can put some conditions before this interlock, and we can use comparators, and we can use contacts and all the same stuff we always do. Or we can just leave this rung empty right here, and then even if we're referring to this interlock for some things to start, this interlock is always going to be true as long as we don't have any conditions here. Sometimes we want to do it that way. We don't want to use an interlock. So, hey, we can just leave this alone and act like it doesn't even exist. Sometimes we do need an interlock, and we can drop the conditions here. Supervision, this is something that we are not going to be using, okay? If you're using like a remote diagnostic system that's using ProDiag, and it's looking for certain things to be, it's basically analyzing your process, and let's pretend you get into a step but the interlock isn't met, and it should be. Well, if you determine that hey, there's supposed to be an interlock met and it's not, then you can energize this supervision, and your diagnostic software can pick that up, and you can require operator engagement and things like that. And there are other simpler ways to do that without getting into this very high level of detail to bring somebody's attention to something not working right. So we don't have license for ProDiag anyway, so we're not going to be experimenting with it, using it, because in 99% of the programs you write, you're never going to be using this stuff anyway. So if you want to pick it up on your own, go for it. But as far as teaching it in the course, I just refuse to teach something that 99% of the people in this course are never going to use. Actions. Okay, this is the real bread and butter of a step. This is something that we're going to be using all the time, incessantly, when we're programming with Graph. Before we get into that, I'm just going to real quickly jump and skip ahead to transitions. And, here you go. This looks a lot like the interlock up here, right? We've already got our action on the rung. And if we don't put any conditions here, that action is going to happen automatically. Okay? There's not going to be any delay whatsoever. Those, as soon as we get here, those are going to be energized. We're ready to go. Well, naturally, for this step, we probably do want some conditions here, because we probably don't want our step to just, we hit it and immediately jump to the next. There are some cases where, you're going to have some really simple actions like, set a few bits to a certain, a few things like, set this bit, set this value to, 20, call this function, and then we're done. And if that's the case, hey, we can just go ahead and leave this transition conditions vacant, and we're just going to do all of those things instantaneously and pop down anyway. But normally, we're going to want something. So like in our example of heating up water in a tank, here is where we're going to come over here to graph, ladder, comparator. We're going to pull in a greater than, and we're going to say, tank temp, and it's going to need to be greater than 100 degrees or something like that, and define that as an int, and create that a tag for that. But this is where you're going to do those things. And you can also use some more complex logic on these two rungs. So if you need to say, well, there's a possibility that we might have multiple ways to satisfy this condition and engage the transition, you can define a more complex logic here, just whatever you need. But the nice thing is you don't have to. If you leave it like this, your transition's just always true and always ready to happen. Okay, so we've covered everything in here except actions. And look up here, you can also create comments. So if you want to add some documentation, this is where it would go. Okay, so if you want to put some explanations as to what somebody's looking at when they come in here, and what we're trying to accomplish, and what this step's purpose is, then that's where that would go. Moving into actions, here we go. We've got interlocks, events, qualifiers, and actions. And this is where things get a little bit more complicated. So remember, we had our interlock up here, and we said, maybe we have a condition on that interlock that, we're looking for something to be true before we interlock it. Well, down here, we can have multiple steps, and we can refer to the interlock and say, before we do this step, whatever that step is, so maybe we're going to, count down something every time this step happens, or maybe we're going to give ourselves a delay, and we're going to, set a bool after a certain amount of time. So call it delay over, and give ourselves a t-pound 5-second delay. Okay, so maybe we want to put that interlock there, and that's what's going to start this step to happen. And then we say, well, and then we're going to transition out only once the delay is over. All right, so that's how that works. And allow to run step, whatever. So we can have a condition on our interlock. Once that condition is satisfied, the interlock allows this step to happen, which is basically going to wait 5 seconds before setting this bit. And once that bit is set, then we can transition to the next stage, the next step. Aside from that, we can look at different events, and here we have an alarm acknowledgement. Okay, that's more looking for an alarm being acknowledged in kind of using one of those diagnostic systems that gives us a separate interface. I prefer to program my alarms manually rather than using the built-in alarm management in this environment. So, you know, you can get into that, but I think it just makes your program more complicated and doesn't really add a lot of value and functionality if you aren't using one of these monitoring systems. So take that for what it's worth. When we get to L0 and L1, that's these, when you see these zeros and ones, I want you to think of those as being one-shots, as being rising and falling edges, like our P trig and our N trig when we were going through bit logic, okay? So when the interlock connection is satisfied, that's L0. What that means is when that interlock first becomes true, then we want to do this. Or if at some stage we lose the interlock, and you know, we had the interlock, it was good, but now all of a sudden we lost it. Whatever, you know, was enabling that interlock just became false. Well, you know, then we can take some action at that time. The R1, that is for a condition that you can set coming into your actual block outside of your sequence. So whenever you're dragging this graph program block onto, like, let's say your main, or you know, whatever program you're putting this into, you've got a lot of different inputs and outputs that are, you know, going into and can come out of this sequence. I'll show you that later, but this is where you actually set this condition, and you're detecting that event in here. That's not something that we're probably going to be using in here. We're going to be using these sequences very simply. Outgoing step and incoming step. Incoming step is when we first get started on this step. So basically the first scan once this step becomes active. And outgoing step is the last scan before we transition out of here and end this step. And then V0 and V1, monitoring errors, you know, that ties back to supervision. And if we're, you know, using supervision, when that becomes energized and or de-energized. So for us, if we're doing anything with events here, it's probably going to be incoming step and outgoing step. Those are really the two that we will probably end up using here. As far as any of the rest of these, you know, maybe we'll one shot off of the interlock, but I really doubt it. Most of the time, I think what we're going to be using is outgoing step or incoming step. First scan once the step becomes energized, and last step once the step becomes energized. And we won't even be using those probably very often. And the nice thing is, interlock is not required, event is not required, and then we get to qualifier. And this is where, you know, we actually start, you know, with something that's mandatory and that's going to tell us what, you know, kind of action we're taking. So I don't love the way that we have this qualifier and action, and I really wish we had some better qualifiers, like, you know, I don't know, maybe a one-shot qualifier that says do this one time. That would be awesome. But we've got a hold timer and reset, extended pulse, turn off timer, you know, a countdown, reset, you know, okay. You know, these are all very specific, you know, counting up how many times we, you know, do come to this step and things like that. Activate a step, deactivate the step. Here's something that's actually kind of useful to us. You know, we can create a pulse set for a limited time, set something as long as the step is active. Okay, this is something I like, because here we can use this to create an indicator that we can refer to in an HMI and tell us that this step is running, okay? So that's pretty useful right there. setting something to 0 or setting something to 1. All right, that's pretty useful. So if I want to just set a bit, there, done. Just define that bit right there, not a problem, okay? So that is very useful to us. Retentive on delay. So, if this step is starting and stopping and things like that, and, we want to count all that time up towards something happening, that's just something really specific. Might happen eventually that we need to use something like that, but probably not. And do you know what I don't see in here besides a simple one-shot, which, would be really nice, is, there isn't anything to, set a value or move a value. And that's something that I could really see us wanting to do here is, change a set point value or initialize a value. And, it doesn't give us that kind of qualifier. So the only thing that we can do is call an external function and have it do that. And even that is something that, we really can't just call it one time unless we're calling it like at the very beginning or at the very end. So, if let's say at the beginning of this step, we wanted to, zero out a value, okay, that's something that genuinely could be happening, right? So we take our incoming step, and then let's pretend, like we've got a function, okay? So, we'll just call this init vals, okay? So initialize our values, and, we'll make that something simple. We'll just make that a ladder, and that'll be a function, okay? So we've got this function, and I'm not even going to, create any logic in there, but I can drag this over here and just drop that call. And you see it automatically filled in my qualifier set as long as step is active, okay? And, even though it's saying set this for the whole time the step is active, we put an event here that's saying, only do this once, okay? So, again, you see why I'm not loving this interface, right? And, so then we can call that init values. It should only call one time, when we first get into this step. So, like that, we can initialize things. Being able to call functions in here, that is what really makes this graph powerful, okay? That's where, instead of trying to wrestle with qualifiers and events and all this stuff and, okay, I want a timer, on delay, okay, you can do things that way, but it's so limited as far as what you can do in here that, if you just use functions and, even function blocks or program blocks, and call them from in here and make those things happen, and then just monitor whatever conditions you want down here on the transition, okay, that's where these things become pretty simple to use. And because you can define your whole sequence right here in a graphical format, that makes this thing kind of useful, okay? That's when, I can see this thing working. But, otherwise, just being a slave to the qualifiers that they give you and, without calling things in, man, this thing would be painful. So that's really what you have to know. That's the basics of what's going on inside of one of these steps. And this is going to be, a struggle until you actually create a few processes and work through it and, really do something with it. But for right now, I really just want you to have seen things and get an idea how they work.